Okay, so in this lesson, we're going to begin discussing what we mean by evaluating square roots or find square roots. And so basically, let's go ahead and define what a root is. So it's very important you understand what we mean by a root. For example, square root, cube root, fourth root, and so on. Now, in this lesson, we're going to be focused just on square root. All right, that's all we're focused on in this particular lesson. So we'll just be dealing with square roots. But let's talk about what a root is. So we define the root of a number by its reverse operation. And so the reverse operation of a root of a number is this. It's raising a number to a power. Okay? So when we talk about a root is we define the root of a number by its reverse operation. When the reverse operation is raising a number to a power. So for example, so let's consider this. So let's consider this idea. So the square of 6 is 6 squared, right? So the square of 6, and that's what the square of 6 looks like, which is equal to 36. So 6 times 6, 36. Okay? Now we're about to talk about this a little bit further, but let's just look at a couple more. The square of -7 is -7 squared. Now be careful, -7 times -7 is a positive 49, so don't say -49. It's a positive 49. And then let's do one more. The square of 1/3, which is 1/3 squared, which means 1/3 times 1/3 is 1/9. All right. So this part here is what this is. So raising a number to a power. So I'm raising 6 to the second power. I'm raising -7 to the second power, and I'm raising 1/3 to the second power. Okay. Now I'm going to use this to talk about what a root is. All right, so the reverse operation of squaring. See right here, I squared here. So the reverse operation of squaring a number is finding the square root. So again, and that's going to be important later on in our lessons when we solve radical equations. So the reverse operation of squaring a number is finding a square root of the number. Okay, so for example, all right, example. I'm going to write the word example here. And we're going to use this here. So example, a square root of 36. So remember a while ago we said the square of 6 is 36. So remember the square root is a reverse operation. So the square root of 36, so the square root of 36 is 6. The square root of 36 is 6. What's inside the parentheses is 6 because 6 squared equals 36. Okay? So the square root of 36 is 6 because 6 squared equals 36. So if I take the square root of 36, I will get this. I will get this base right here. Okay? All right, let's look at the second one right here. A square root of 49 is, now you may say, well, a square root of 49 is 7. That's true, right? That is definitely true. Notice I use the word A square root of 49 is 7, but also what? -7. So a square root of 49 is also -7. It's not just 7, it's -7. Same thing here. I just mentioned that one of the square roots of 36 is 6. What's another square root of 36? -6, because a -6 times a -6 is 36. All right, but notice I'm just using the word A here, just singular, A. So a square root of 49 is -7 because -7 times itself is 49. Okay? So if I take the square root of 49, I get what's inside the parentheses. I get the base. So the base is negative 7. And so a square root, let's do the last one right here. A square root of 1/9 is 1/3 because 1/3 squared is 1/9. So if I do the reverse operation, the square root of 1/9 is this base here. So 1/3 squared is 1/9. The reverse operation says that the square root of 1/9 would just be 1/3. So the inverse operation or the reverse operation of squaring is square root. So that's what it says. So the reverse operation of squaring a number is finding the square root of a number. Okay? All right, so in general, the number b is a square root of a number a if this occurs. So in other words, see right here, let's do 6. So 6 is a square root of 36 if you can say 6 squared is 36. Negative 7 squared is 49. 1/3 squared is 1/9. Okay? So if you can say b squared is a. That's what that says. So in general, the number b is a square root of a number a if when you take the square root of a, you get b back, or if you take b and squared, you get a. That's what that says. Okay? So the square root of a would be b. All right? Okay, so just like this, the square root of 1/9 is 1/3. The square root of 49 is negative 7. The square root of 36 is 6. So the square root of a is b. And that's what that statement says. Okay? All right, now, let's look at terminology. All right, so the next thing we're going to look at is terminology. Okay, so you've all seen this symbol. And you've seen the symbol from when you were in probably middle school or even in lower grades than that. But remember, this symbol means square root. So this symbol right here, that looks like this, is used to denote the positive or the principal square root of a number. All right, so that's important. So whenever you see this symbol, and it's just this symbol, then that means, and you're going to see some examples in a little while, that means I'm looking at the positive square root, and another word for the positive square root is a principal square root. So sometimes you'll hear the word principal. Just remember, when you hear the word principal square root, you're looking for the positive square root. So that's important. Okay? All right, so let's look at this example. So here's the example. So if you see something like this, it's important you know how to read this. So this is read as the square root of 64. In particular, I'm looking at the positive square root of 64. See, there's no sign in front. You're looking at a positive square root. Okay? And then in a little while we're going to look at the negative square root. But right now, if all you see is a positive square root, then that's also called the principal square root. So the principal square root of 64 is 8 because, remember what we just talked about here, all this right here, because when I square 8, I get 64, because 8 squared equals 64. Okay? And 8 is positive. Okay, because you're looking for a positive square root. So don't say it's negative 8. All right, that's important because this says I'm looking at the positive square root of 64, the principal square root of 64. The principal square root of 64 is a positive number, so it's 8. All right, and so therefore 8 has to be positive. Okay, now the symbol, okay, so let's talk about the symbol. So this particular symbol right here I'm about to write, and so here's the symbol, negative square root. So that symbol, negative square root, is used to denote the negative square root. So this is the positive square root, and what's another word for positive square root? Principal square root. So when you hear the word principal square root, you got to think positive. And then, so if you see this symbol, that means the negative square root. So this is a positive square root. This is a negative square root. Okay? So there's no sign in front. It's positive. If you see that negative sign, it's negative. Okay, so let's look at this example. So let's suppose we had this then. Our example. Oops. So let's suppose we had negative square root of 64. So a while ago, we saw that the principal square root of 64 is 8. All right. So then the negative square root of 64, what do you think that has to equal? What has to equal? A negative what? 8. So it's equal to a negative 8. It's equal to negative 8 because negative 8, in parentheses, squared is going to equal 64. Okay? And negative 8 is negative. All right, because you're looking for a negative square root. So your answer has to be negative, in this case, negative 8. All right? Okay, now, let's look at this. Okay, so some more terminologies. All right, so whenever you see this symbol, that's called a radical or radical sign. Now, in the next lesson, see, this is square root. In the next lesson, you will see cube root, fourth root, fifth root, and so on. Okay, other types of roots. But again, in this lesson, we're only focusing on square root. So the symbol here is called the radical or a radical sign. Okay? Now, the expression that's within or under the radical sign is called the radicand. So the expression that's under the radical sign is called the radicand. Okay? And so an expression containing a radical is called a radical expression. So an expression containing a radical is called a radical expression. Okay, now, in the next lesson, we're going to look at when we have a radical sign, how do I know if it's a cube root? How do I know if it's a fourth root? How do I know it's a fifth root? Okay, we're going to talk about that in the next lesson. But whenever you see just something that looks like this, that's going to be square root. See how that looks? Square root. Okay? All right. Now, let's look at this example. Okay. So the direction says this. For each radical expression, determine the radicand. All right. So, again, it's important you know how to read this. So how do you read this? This is read as a square root of 8. So we have this radical expression. Okay? So we have a radical symbol, a radical sign. We have a radicand. And so what's your radicand here? 8. So the radicand is 8. The radicand, or radicand, is 8. Okay? This is number 2. Number 2, we have this. So I have 3 times the square root of x plus 4. So remember, the radicand is the part, the expression that's under the radical symbol. So what is under the square root symbol in this case? X plus 4. So the radicand in this case is x plus 4. So the radicand is x plus 4. Okay? All right, so the idea of knowing what the radicand looks like will help you as we go through these lessons. What about this one? So this one says the square root of a minus 4. Now remember, the radicand is only the part that's under the radical symbol. In this case, the square root symbol. So what's the only part that is under the square root symbol? It's just the a. So the radicand is a. Okay, and then finally, if we look at this one, so here you have xy squared times the square root of x divided by x plus 1. So remember, the radicand, so you have this radical expression. So the whole thing is a radical expression. All these are radical expressions because they contained a radical sign, right? In this case, it's square root, square root, square root. But the radicand is the part that's under the square root symbol in this case. So it's what the expression that's under the square root symbol. So what's the radicand? Radicand is x divided by x plus 1. Okay? All right, now let's look at this idea. So I think we have enough information to be able to discuss what this means. So this example says, find the square roots of 25. So remember, a square root is the reverse operation of squaring, right? So the square root of 25, and remember what that looks like. So it's saying square roots. So remember the square root of 25, what's one of them? So what times itself is 25? 5, okay? So the answer, you're going to say 5. And what's the other answer? Negative 5. So you're going to say 5 because remember, 5 squared equals 25. So remember the square root is the reverse operation of squaring. So if I take the square root of 25, I'm going to get 5 back. All right, so the square root of 25 is 5 because 5 times itself is 25. And it's also negative 5 because negative 5 times itself is 25 as well. Now, I just want to make this point, though. You see that 5? So I need for you to go back to our terminology that we used earlier. And that was the fact that 5 here, so the principal square root is which one? It's 5. Remember, the principal square root is the positive one. So this is the negative square root. So the negative square root of 25 is negative 5. So the principal square root of 25 is 5. The negative square root of 25 is negative 5 because negative 5 squared is 25. So let's do this one. So what are the square roots of 225? So what times itself is 225? All right. Now, so here's what some of you can do. Now, this one is easy to deal with, right? Because you knew that 5 times 5 is 25. But what whole number times itself is 225? Well, you may need a calculator for that. So you may say, all right, I'm going to try 10 times 10. All right, 10 times 10 is 100. So you know that my answer has to be bigger than 10. All right, let's try 12. 12 times 12, right? Well, that's 144. Let's try 14. 14 times 14 is 196. So I need to go a little bit higher than 14. What about 15? 15 times 15, hey, there we go, 225. So the square root of 225, there are two answers. One is 15, and the other is negative 15. And the reason it's 15, negative 15, because 15 squared equals 225. So the square root is a reverse operation of squaring. So if I square 15 and get 225, that means if I take the square root of 225, I will get 15 back. So in other words, the square root of 225 is going to be 15. Okay? And so if I look at negative 15 squared is 225 as well. So that means if I take the negative square root of 225, I will get a negative 15. All right, so now what I want you to remember, though, is that the positive 15, that's your principal square root. So the principal square root of 225 is 15. And the negative square root of 225 is negative 15. Okay? All right, now let's look at these. Okay, so let's look at these examples here. Okay, now notice that that here you want to simplify. In other words, you just want to find the square root. So it may say find the square root. So you want to find the square root of 144 without using a calculator. Without using a calculator. This is easy enough to determine without using a calculator. So remember what we did here. We said the square root of 25. The square root of 25 means what number times itself is 225. So what number times itself is 144? Well, 12, right? So this, now also keep in mind, is this the principal square root or a negative square root? That's a principal square root. So the principal square root, because it's positive, the principal square root of 144 is just 12. And it's easy to see because 12 squared is 144. 144. Okay? All right? And let's look at number 2. So number 2, let's suppose we had negative square root of 121. So I want to find the negative square root of 121. So what number times itself, first I'm going to cover this negative symbol up. So what number times itself is 121? Well, 11, right? So the negative square root of 121, negative square root of 121 will be negative 11. So negative 11. All right? Because the negative square root of 121, because negative 11 squared is still 121, the radicand. All right, so always think about this idea here when you're finding square roots. So what number times itself is a radicand? What number times itself is a radicand? Just make sure it's negative in this case. And so you get negative 11. So negative 11 times negative 11 is 121. Okay, number 3, you have the square root of 9 divided by 16. All right, now, this is not that difficult. You're just dealing with a fraction. So really what in your mind you're thinking about, well, I'm taking the square root of a fraction, right? So I have a numerator and the denominator that's underneath the radical. So 9/16, 9 divided by 16 is the radicand. So I can write this as the square root of 9 divided by the square root of 16. And then just look at the square root of 9. What's the square root of 9? Well, that's 3. And what's the square root of 16? What number times itself is 16? Well, that's 4. All right, so there's your answer, 3/4, because you're looking at the principal square root of 9/16. Number 4, you're looking at the negative square root of 16 divided by 81. All right, well, same thing, right? So you can do the same thing we did here. So you can say, all right, well, that's going to be the negative square root of 16 divided by the square root of 81. And so the square root of 16 is 4. And what number times itself is 81? It's 9, right? So the answer is negative 4/9. There's your answer. Number 5. You have the square root of 0.36. All right, don't let that throw you off. So you know in your mind that the square root of 36 is 6, right? So you know that the square root of 36 is 6, but this is not a 36. This is 36 hundredths, correct? 36 hundredths. So there are a couple ways you could think about that, but what do you think that the answer would be? You know it's not 6, and you know you want the radicand to be a decimal 0.36 or 36 hundredths. All right, so you may say 0.6. All right, so if you think about that, it's true because 0.6 times 0.6, so 6 times 6 is 36. You have 2 decimal places, and so notice you get 0.36. So the answer is 0.6. Now the other way you can think about this is this, and I want you to pay close attention to this. In a previous course, you read this as 36 hundredths. So if I want to, could I rewrite this as the square root of 36 divided by 100? Because in this radicand, the same thing as this radicand. And so using this idea here, when I rewrote it, I can write this as the square root of 36 divided by the square root of 100. And the square root of 36 is 6, and the square root of 100 is 10. And so you get 6/10, which is this decimal. So you get 0.6. Okay? All right, now let's look at this. Okay, so here's my next question. My next question for you, and I'm going to write it right here. Let's look at this one. What is the square root of 6? Okay, so I know that the square root of 144 is 12. I easily knew that because 12 times 12 is 144, right? And I knew that the square root of 121 is 11 because 11 times 11 is 121. I knew that the square root of 9 is 3 because 3 times 3 is 9. I knew the square root of 16 is 4 because 4 times 4 is 16. I knew the square root of 81 is 9 because 9 times 9 is 81, right? I knew the square root of 36 is 6 because 6 times 6 is 36. I knew the square root of 100 is 10 because 10 times 10 is 100. What about this? What whole number times itself is 6? 1 times 1 is 1. 2 times 2 is 2. 3 times 3 2 times 2 is 4. 3 times 3 is 9, and so on. There is no whole number times itself that's 6. Now you may say, well, why were these whole numbers? Those were whole numbers because these were perfect squares. So remember your perfect squares. I'm going to go ahead and write this here. So remember your perfect squares. So your perfect squares. So your perfect squares, remember the first, the smallest perfect square is 1, and I'll come back and explain that. Your next perfect square, if you recall, is 4. The next one is 9. The next one is 16. Now here's how I'm getting these numbers. So I'm taking 1 and I'm squaring it. Okay? I'm taking 2 and I'm squaring it. Here's the idea of that perfect square. So you're squaring these whole numbers here. So I'm taking 3 and squaring it. I'm taking 4 and squaring it. So you see 1 squared is 1, 2 squared is 4, 3 squared is 9. And so you see how I'm squaring this? So if I take the reverse operation of squaring, if I take the square root of 1, you get what back? 1. If I take the square root of 4, I get what back? 2. If I take the square root of 9, I get what back? 3. If I take the square root of 16, I get 4. What's the next perfect square? 25. Because the square root of 25 is 5, right? So if I square 5, I get 25. What's the next perfect square? Well, the next perfect square will be 6 squared, so that's 36, because the square root of 36 is 6. Next one, 7 squared, 49, and so on. So there's an infinite number of perfect squares. But notice, 6 is not a perfect square. So you may say, well, what do I do? I can't determine that very easily, right? Okay, so what you're going to do now with something like this, chances are, depending on the directions, you won't do anything. That's it. You'd leave it like this. You cannot simplify this. See, here I simplified the square root of 144. It's 12. Here I simplified negative square root of 121. It's negative 11. I cannot simplify the square root of 6. I cannot simplify. So this can't be simplified. All right, simplify. But here's one of the things you can be asked to do. So here's one of the things you can be asked to do. So one of the things you can be asked to do is this. Approximate the following square roots, so these are going to be square roots, to the nearest thousandth. And that's where you're going to need your calculator. All right, so let's look at our calculator. All right, so approximate the following to the nearest thousandth. Okay, number 1, the square root of 6. All right, so here's how you use your calculator. So on your calculator, and hopefully you have one of these where you know how to use it. So you're going to locate the square root button. So for me, the square root button, you see it right here, right above the x squared button. It's a different color, so you have to press second to get to it. So you're going to say second, then press x squared. So you get the square root right here. Then press 6. And I don't have to close the parentheses, but if you feel you want to, then go ahead and do it. So I close the parentheses and then press equal. And there we go. Now, remember, it's very important you see that the square root of 6, even though it looks like it terminates right here, remember that's as far as my display goes. So the square root, whenever you're dealing with square roots, if it's not a whole number, then this is going to be a decimal that doesn't terminate, and there will never be any repetition. So the square root of a whole number, well, the square root of a number that's not, and the radicand is not a perfect square, this is going to be irrational. So that's an irrational number. You can't write it as a fraction. So as a rational number. So in the directions, though, it said round to the nearest thousandth. Remember, the thousandths is this. So if you have your decimal point right here, this is the tenths place. Remember, tenths. This is a hundredths. And this is a thousandths. Okay? So sometimes in thousandths, THS, sometimes instead of saying round to nearest thousandths, they'll say round to 3 decimal places. So you may see the phrase round to 3 decimal places. So 3 decimal places means 3 digits behind the decimal point. Okay? All right, so listen carefully to this. Do you see how I have all these digits and there's an infinite number of digits? My display only stops here though. And here's my next question. Are there going to be any repetition in here? Or are any of the digits going to repeat? No. Okay, so this is not a rational number. This is an irrational number. Okay, so what I want you to think about is this. If I look at my display again, I have 2.4494897. I'm going to stop there. And I went around to the thousandths place, so 3 decimal places. 1, 2, 3. So I went around here, right? That's what I round off. So remember though, in order to round off here, I got to look at the digit next to it on the right. So I got to look at the remember, tenths, hundredths, thousandths, 10,000. So I got to look at the 10,000ths place. Well, that's 5 or larger than this. Then I got to add 1 to this. But since it's less than 5, it stays 9. So the answer is going to be approximately equal to, that's a symbol for approximation, 2.449. 2.449. Okay? All right, number 2. Let's go number 2. Suppose we had negative square root of 18.25. So here's my question. Is the radicand a perfect square? No. No whole number times itself is 18. In fact, if I can get back to it, notice that the 18 is between 16 and 25, right? So that there's no perfect squares between 16 and 25. Okay, so that means that this is an irrational number. So that means if I want to do anything, I can say I can leave it like this, but if I'm asked to round to the nearest thousandth, then I'm gonna have to use my calculator. So in your calculator, and you know the answer will be negative, right? Okay, so just take the square root of 18.25. So I get square root, press your square root button. Okay, so oops, sorry. Let me clear. So second square root, all right, then 18.25, close the parentheses, press equal, and notice I get this irrational number. And I want to round to the thousandths place. So 3 decimal places, 1, 2, 3. So I got to look at the 10,000ths place right here. So that's a 0. So that means that 2 will stay 2. So the answer is 4.272. So negative 4.272. Okay? Number 3, you have the square root of 125 divided by 18. All right, so 125 divided by 18. 125 and 18 are not perfect squares. So the direction, that's why the direction says round nearest thousand. So let's go to approximate this, because I know I'm not going to get a whole number. I'm going to get an approximation. So I'm going to press square root, just like this. Okay. Oops, I keep doing this. Okay, square root. Okay, let me clear it again. Okay, square root. Okay. Then 125 divided by 18, close the parentheses, press equal. And you get 2 point, all right, you want to round nearest thousand, so that's three decimal places, 1, 2, 3. So the next digits are 2, since that's less than 5, this will stay at 5. So 2.635. So 2.635. Okay? All right, number 4, you have negative square root of 0.002. All right, so let's see what that is. So we know it's going to be negative. All right, so square root, okay, 0.002, close the parentheses, press equal. All right, 3 decimal places, 1, 2, 3. So this digit is 5 or larger. It's a 7, so it's greater than or equal to 5. So this 4 right here will become a 5. So you got to add 1 to this digit, to the thousandths place. So 0.045. So negative 0.045. Okay? All right, now one more thing we need to talk about, and it's this. Okay, so I want you to notice something. The radicands. So this radicand was positive. This radicand was a positive 121, right? This radicand was a positive 9/16. This radicand was a positive 16 divided by 81, and so on. Positive 0.36, positive 6. Notice even when approximated, the radicands were positive, 18.25, 125 divided by 18, 0.002. They were all positive. You didn't see any that were negative, right? None of those radicands were negative. So here's my question to you then. Here's the question. Is the square root of a negative number a real number? So is the square root of a negative number a real number? All right, so that's what I want us to look at. Okay, so let's look at that. So is the square root of a negative number a real number? So in other words, I'm asking this. Here's what I'm asking. So I'm asking this. So is the square root of a negative 9, let's say, okay, my radicand's negative. Is the square root of a negative 9 a real number? That's what I'm asking. All right, well, let's think about that. So basically we need to ask ourselves this. So we need to ask this question then. So is there a real number whose square is negative 9? Right? So because remember when we did this, let me go back to this right here. So remember we said the square root of 144 was 12? That's because there's a real number 12. I can take the real number 12, multiply by itself, and will give me 144. So the question is this. Is there a real number times itself that's going to equal negative 9? That's the question. That's what this is asking. Okay? So is there a real number whose square is negative 9? So is there a real number when you multiply by itself is negative 9? So you may say, well, yeah, what about negative 3? All right, well, think about it. Is negative 3 times a negative 3 equal to a negative 9? The answer is no. Because what's a negative 3 times a negative 3? A negative 3 times a negative 3 is a positive 9, right? Then you may say, well, what about positive 9? Well, the same thing. What's a positive 3? What's a positive 3 times a positive 3? Well, it's a positive 9. It's not negative. So is there a real number? Is there a real number whose square is negative 9? No. Not at all. Because any positive number times itself is positive. Any negative number times itself is positive. You're never going to get a real number multiplied by itself that's ever going to be negative. All right, so here's what I want you to think about. Okay, so since there is no real number whose square is negative 9, since there is no real number whose square is negative 9, we say that the square root of negative 9 is not a real number. So that's what we say. We say the square root of negative 9 is not a real number. So in general, a square root of a negative number is not a real number. Now later on, in this course, you're going to see that we can define the square root of a negative number using imaginary numbers. Okay, but for right now, in this lesson and probably the next, I want you to always remember that the square root of a negative number is not a real number. Okay? All right. Now, the other way I want you to think about this is this. So let's suppose you use your calculator with the square root of negative 81. So here's my question. Is the square root of negative 81 a real number or not a real number? Square root of negative 81 is not a real number, right? Because there is no real number times itself that's ever going to be negative. No real number times itself, no real number squared, is ever going to be negative 81. So if you look at your calculator, I want to show you what's going to happen if you put that on your calculator. So if you say square root and then negative, you press the negative button. Make sure you press the negative button. 81, close the parentheses, press equal, you get this domain error. And so some of it may get domain error, some of it may get just the word error or something else. But that means that you can't take the square root of a negative number. So this is not a real number. Okay? So that's what you would say. All right? So let's look at this example. All right, so determine whether the expression represents a real number. So I'm going to write an expression down here. I want you to tell me, is it a real number or not a real number? Okay, number one, the square root of 25. Is the square root of 25 a real number, not a real number? Right away, you need to tell me it's a real number because the radicand, all you have to do is look at the radicand. The radicand is what kind of number? It's positive. So as long as the radicand is positive, remember we're talking about square roots only. As long as the radicand is positive, there is a real number times itself that's going to be that radicand. And it's going to be, in this case, 5. So this is a real number. So the square root of 25 is a real number. In fact, it's 5. But you didn't have to find it. You just have to tell me, is this a real number or not? And all you have to do is look at the radicand. Number 2, what about the square root of a negative 6? Is the square root of a negative 6 a real number? Right away you say what? No, because the radicand is negative. There is no real number. There is no real number times itself that's ever going to be negative 6. So it's not a real number. Okay? What about number 3? Number 3, we have negative square root of 15. Now, you be careful. Remember, you got to look at the radicand. The radicand is 15, right? So don't let that negative in front confuse you and throw you off. You did something like this earlier. The square root of 121, negative square root of 121 is a real number. The real number is negative 11. So as long as it's on the outside, you're fine. You just got to look at the radicand. The radicand has to be positive in order for you to get real numbers. So this is a real number. Okay? All right, number 4. All right, number 4, you have negative square root of a negative 22. All right, again, what's the radicand? All you look at is the radicand. Can I take this, even though there's a negative out here, can I take the square root of a negative number? The answer is no. So it's not a real number. And then finally, number 5, look at number 5. You have the square root of a negative, in parentheses, negative 72. All right, now, you remember, you got to remember something in the past that you've learned. So this right here, see when you have a negative and then there's a parentheses with a negative number? You can think of this as the opposite. Okay, look. You can think of this as, this right here as meaning the opposite of negative 72. And so what's the opposite of a negative 72? Well, the opposite of a negative 72 is what? Positive 72. And so this right here means the same thing as the square root of 72. And now tell me, is this radicand positive or negative? It is positive. So is the square root of a negative 72 a real number or not a real number? Well, since it's positive, it's equivalent to 72. It's a real number. Okay, it's a real number. All right. Okay, so I think we have enough information for you to understand the idea of evaluating square roots. And so that's going to be the end of the lesson with square roots. In the next lesson, which will be probably quicker because as long as you know how to deal with square roots, then the next lesson, which is going to talk about the other roots, like cube roots, fourth roots, and fifth roots, and so on, you should be fine. Okay, so that's the end of this lesson.